Well, hello everyone. My name is Javier Marcos, and this is my colleague Juan Galiana. We both work as pen testers for IBM, and our talk is the title is Pwning intranets with HTML5. Basically, what we are going to present is this is the agenda for the presentation: how the attack works, how we are going to discover stuff in your network. What type of information and what resources are we going to extract from your infrastructure. We are going to draw some diagrams that your network administrator will ask us for them. We are going to, once we have located stuff in your intranet, we want to access those machines, and we are going to exploit some services there, and we are going to show you the demo. And then we're going to some conclusions. If you have any questions, just jump in and we try to answer them. So basically, how the attack works. Let's start off with the diagram of what we are trying to do. This guy here. Oops. This guy here wants to extract information from this secure intranet, which are some clients connected to that secure intranet, and he's going to force those clients to visit some websites that he controls to run some code, and with that code that will run within the intranet, he will be able to work around the firewall, IDS, IPS, all the passive detection systems that can be in the intranet, because the intranet is secure, isn't it? So he's going to do that through the internet. So this is basically the idea of this presentation. How we are going to do that? Let's start off with what's HTML5. Everyone is talking about HTML5. So well, this is some of the reasons that why you would use HTML5 or any other users want to use HTML5. It has backwards compatibility with HTML4. It's just a new set of new tags. Some tags are deprecated. New tags in, new tags out, with new additions in JavaScript, new APIs, and new CSS content. It has also new cool features like Canvas, WebGL, geolocation, native media support. You won't have to use anymore the Flash plugin. And then you can access the other domains from a different domain using the cross-resource sharing requests, also known as CORS. And well, you will have to eventually, because the modern browsers now, they are shipping their browsers with support on them. And this is the features of HTML5 that we want to focus on. We want to use WebSockets, CORS. We want to use web workers to parallelize some JavaScript code, and we want to run using the new features of the JavaScript APIs. Now, what we have HTML5 as base of the attack, we are going to focus on Beef. Any of you know of Beef? Well, Beef is it stands for Browser Exploitation Framework. It's a very nice way to scare developers when you tell them you have a cross-site scripting, and they say, yeah, it's an annoying pop-up, but what can happen? Then you show them what can you do with Beef. You can do really cool things. It works as a command and control center for hooked browsers. The browser acts like the zombie of a botnet, and with Beef you can run code on that machine. It has several modules to run stuff, and you can extract information from the browser. You control the browser of the victim. And we are going to focus on this. It was the first version of that was developed by Wade Alcorn 2005. It was developed using JavaScript and PHP. The new version is written in Ruby, and the modules are written basically in JavaScript. Now we have HTML5 and then Beef. How we are going to kick off the attack? Well, what we want to do is just spot a person that has access to the internet, that is connected in the internet, and then we are going to force him to visit a website that we control, that we can just run our code at, or we can just use a phishing attack to do that. Can do some social engineering and know which forums the guy visits while he's in the office. We can kick off the attack from there, or we can use URL shorteners that is in Twitter, Facebook, any social media or social engineering techniques can work for this. The point here is to make the guy who is within the intranet run the code that we control. And we are going to use BIF as the command control center for that. And all the tools that we wrote for this, they are part of BIF already as modules. You can grab them in the next release, which will be the 10th of November. And well, those modules will run with HTML5. And now we decided which tool set are we going to use. What can we do?
Okay. So we're going to use it works. Yeah. Intranet footprinting that basically is get as much information as you can about a network. So we want to know we want to locate the network range to what the victim is connected to. So once we have that network range, we will identify the active machines on the network and the internal host names. Then we want to extract information about these machines. So we will discover the open ports to map them to the service running. And we'll try to do a basic operating system fingerprinting, and then create a graphic and map the network. So for that we are going to use BIF, the browser exploitation framework. BIF has two main components, the server side that is written in Ruby, and the client side that is it runs in the victim, and well, it's basically a set of modules. Here we have an image that we can see the list of hook browsers. With a quick look, we can see that we have a victim, and it's running Firefox with Linux. Well, it's kind of a control panel to manage hook browsers. So well, it comes out of the box with a set of modules. We can see there the module tree, so we have different categories, like exploits, the Metasploit integration, network, browser, and other categories. Well, you can as well develop your own module. So well, each module has 3 files. The first one is a config file, in which we set the name, the category, and well, basically the configuration for that module, the browsers in which that module runs. The second one is a Ruby file. We have to define there the parameters for that module. Well, it's an important file because the core and the server needs that file to run. And then the last file is the JavaScript code, in which we can use all the features of HTML5, and it's the code that is going to run into the victim browser. So that is the important part. So first of all, there is a module called Discover Internal Network that we can use to get the internal IP address of a victim. So if we run that module, it uses JavaScript to get the internal IP address, and we can get, here on the bottom we can see an image that the module returns the internal IP address of that victim. Well, another module we developed is the ping module. So, well, this is like the ping command developed in JavaScript. We are going to see now how it works. We can define IP address. Here we have a couple of examples. It will returns if the machine is alive or not. Well, there we have the module tree, so it's depending of the network category. Well, it works calling from JavaScript to a Java static method, but it's not do not requires user interaction. So normally when we when we have to run Java code in a browser, like an applet, we need the user to accept that he wants to run the applet. But in this case, as it's a Java static method, the user interaction is not required. So we can run that code, and this code will run in the victim browser without any pop-up or alert. So here we can see that we not only can specify a single machine, we can as well give a range. So we can scan a whole class C network. In this example, so in the image, we can see that the module will return all these active machines in the network. There is another module called intranet footprinting that is, tries to discover web servers in the port 80 or 8080. So that module scans for Apache, IIS, and known routers and printers. Well, when we do our HTTP request from a browser, if it's cross-domain, we can't read the response. So how it works is it tries to load an image, and then handling the onload event checks the size of that image. So the module has a database with known images and the sizes, and then checks for that size, and if it's the same, so it knows that it's, for example, Apache 2 because that image was only in Apache 2. But well, if we try to scan all the possible subnetworks, that's not practical. We need a lot of time. So what happens if we have an interesting host in a random IP address? For example, a known host like intranet.company.com. If we try to scan every subnetwork, we can't guess that it's in that IP range. So we're going to use a different approach here. We're going to use DNS enumeration. Well, DNS enumeration is a known technique that is around for a while, and well, it's based on two key ideas. The first one is that most of the important servers have a DNS associated to them. And well, the second one, and the most important, is that if we try to resolve, for example, intranet in a web browser, the web browser will append company.com because the configuration of the DNS tools. So well, we have a problem that in JavaScript we cannot resolve DNS entries, but we can try to make cross-domain requests with cross-origin resource sharing or WebSockets, and well, have a look to the time that the request takes to come back, and depending on the time, we can see if that host exists or not. So well, for example, we can try to resolve known hosts like FTP, intranet, or web server, or something like that. So we define a dictionary that, well, in that case, the tool has one by default, but you can provide another one. So the web browser starts to try every hostname, and we'll get the list of the ones that takes more time to resolve. So that means that the host exists. And well, that command will come back with a list of all the host names. So well, now that we know which machines are alive, doing a ping sweep or doing DNS enumeration techniques, we're going to try to extract more information about these hosts. So the next step is try to see which ports are open in those host names.
So now you know which machines are alive in the network, and even if you didn't figure out what was the IP, but you know that machine, because of the name, is there. So now let's try to scan what ports those machines have open. It's port scanning is kind of looking at what's the purpose of a building, looking at the door. If you see a very secure door in a bank, probably, well, something is very secure in there. So it's the door should be secure enough. So it's something like that. The most known port scanner is Nmap, and Nmap is a great tool to run when you are within the network. But when you are outside of the network, we are trying to kick off this attack in a secure intranet. So Nmap is not an option. So we want to get some basic information, like basic OS fingerprinting or service proving to see which services are running in those machines. We are going to use these. Sometimes when you find a port that appears to be open, it's filtered. That's also some information. Means that something interesting is there. A firewall can be protecting that, so it's also information even if you cannot access it. So it's also good to know. And well, the point here is to get as much information as you can, and then later on you can analyze that information and see which ways you can take to kick off the attack. The interesting thing here is most of the intranets they are not filtered because they are running tests, they are developers running code, there are performance tests, there are reliability testing going on. So if you start deploying firewalls or IDS, then they will start having performance issues. So most of the internet they are not filtered. That's good for us because it means that we won't have any problems and anything stopping our request. And this is just playing HTTP traffic. So it's good to discover services that are there, and then if you want to kick off an APT, then you have that information. The basic port scanning we implemented will tell you is the port is either open or closed. You can enable a more verbose mode, knowing if that the port is filtered or it took too long to discover. But that's you can do that. And we are taking the 3 different approaches to scan the ports. We are using the classic approach, which is using image and iframe tags. Using the source attribute, you can specify which IP and which port you can load the resource from. That's complemented with JavaScript. You can process all the requests based on its timing. The whole thing is based on time. So based on the events on load and on error, then you can figure out things. Then the HTML5 approach, it's using cores and WebSockets, which will let you do basically the same with JavaScript as well to handle all the events. There are some problems to these approaches because, well, WebSockets and cores they took some things into consideration when designing the thing. So there are some security measures for that. So if you try to load a known port like SSH 22, it will tell you no, you cannot access that because I'm pretty sure that there is no thing there that you are looking for. So it's blocked, and in Firefox as well natively can block you to do that. But that's not a problem because it was discovered, it was explained by Jeremy Grossman back in 2005. Using a different protocol than HTTP, then you can work around this protection. And in using Wireshark to see how the port scanning we are running looks like, it's exactly as the Nmap TCP scan, which is the simplest scan you can run in Nmap. So here, as you can see, there's you will have that image in Firefox if you try to load the 22 port, which is known to be for a different service, using the HTTP :// IP or hostname :22. WebSockets and cores will raise an exception and won't let you load that content. But if you use FTP, then you got it, and you can still access that. I think if it was still Firefox 3.6, it let you to use the protocol Gopter, which now is no longer supported, but it works really well in the Internet Explorer, Firefox, Google Chrome, and Safari. And as I said, it's based on timeouts. We provide the values for normal intranet that they work out of the box in different browsers, but you can configure those for your own intranet. So this is how the module looks like. It will be under the network category, and then you can provide the scan, the IP to scan or hostname. Then you can provide the specific port to scan. If you put the default string, it will take a default list of ports of 180 ports, start taking from the most used ports that Nmap uses. It's also correlated with a list of known services for those ports. So it will, if the port is mapped to a known service, it will tell you as well. And Then you can configure the timing for what to expect for a closed port, what to expect for an open port, and then what to expect what time to specify between requests, because you don't want to run all of them at the same time. It will it will raise some suspicions. The default list of the ports, which is 180 ports, will take to scan around 5 minutes. So it's not too bad. And if you put your script in a website which runs a video, for example, Nyan Cat is great because it lasts like 7 minutes. So while the person is watching at that video, then you can start, you can run your scans in the background, and it really works well. So now we have which machines we have connected, which other machines are connected as well, and we discover them by domain and which ports they have open. Now we want to put them together and then really provide this diagram to some people, the project managers mostly, they don't want to see a list of numbers and names, so they want something graphic, some eye candy, to see in a quick look how to see what's going on in the scan. So we just did this to make look good, and it's also based on the port patterns. It's done a basic OS fingerprinting as well. For example, if the port AS22 is detected as open, it's most likely that would be a Linux box, and if the remote desktop is open, that would be most likely a Windows box, and so on. So this is how it looks. It's not too bad, like, well, this is all based with JavaScript and CSS, so it can be embedded in any websites or beef as well as command control. So now we have located the machines that are alive, the ports, the services that are running. Now we want to start having serious fun here. So we want to communicate with that and start exploiting things.
Okay, so, well, until here we extract enough information about the intranet. But well, we got the active machines, ports, service running, and now we are going to show a technique tool that is interprotocol. That technique permit us to launch HTTP request from a web browser, but to non-HTTP web service. Well, non-HTTP services. So how we are going to do that? Well, playing with post forms. So well, when we create a post form, the encoding type is by default URL encoded. But there are a few others like plain text or multipart from data. Multipart from data is the encoding type used for file uploading. So well, we can put whatever we want there. So we're going to launch a request from the browser to our service, and the service will ignore the lines like the HTTP headers, but will execute the commands that they understand. So we are going to put an example here, like, well, this, let's imagine we have an IRC server, and we put in the post payload IRC commands. So if I'm talking here about IRC, that can be whatever other protocol we want. So well, the server, well, I removed the part of the HTTP headers. Here we can see two of them. So the server depends on the implementation, and the tolerance will ignore that HTTP headers, but then it starts to proceed each line. But when it arrives to the IRC commands, the IRC server will start to execute that commands. So it says that we are going to change our nick, we're going to join a channel, and then send a message to that channel. Well, I'm not going to give more details here because we are going to show that in the demo later. But we not only can communicate with non-HTTP services, we as well can try to exploit them. So as we have seen before, we can try to recognize if we are in front of a Apache server, and we can do a port scanning, so we can map that ports to know what services are running. So if, for example, we discover an asterisk or another type of service, and we have a list of known vulnerabilities, we can try to send them to the service to see if the vulnerability triggers. So, well, the idea here is we can see better with the diagram. So, well, the attacker doesn't have access to the server directly because it's in the internet, but it controls a website that the client is browsing. So it can control the browser of that victim. The attacker forces the victim to launch a request to the to the server with the payload, and if the vulnerability triggers in the server, it will execute the shellcode there. And the shellcode can be whatever the attacker wants. If it's a backconnect shell, when the vulnerability triggers there, the backconnect shell will connect to the attacker, and the attacker will have full control over the server and over the intranet. So that's the idea behind that. And well, there are a couple of working exploits. One of them developed by Wade Alcorn with asterisk server. And well, it's quite cool that he can exploit and get executed a shellcode in the asterisk server that is not talking HTTP. So well, now it's time for a demo. Okay, so here we're launching BEEF, the browser exploitation framework. Well, BEEF provides with the URL of the admin panel. So well, this is the admin panel. This is the website that the attackers will see. Here on the left will appear the victims. Now we are going to open a basic demo. This tab acts as the window of the victim. So in the admin panel will appear a new victim in a few seconds. There we go. So well, here we can see the information about the victim. Well, we can see the operating system and the browser. We can see as well the plugins that browser has, the internal IP address as well, if it has Java enabled, Flash, WebSocket support. Well, this is a second victim that we connect that is running Safari in Mac. And well, the same approach, we can get the information about that victim. Well, so same as the other, like the browser, plugins, screen size, has Java enabled, and so on. So well, if we go to the tab commands, here we have all those modules we were talking about. They are split in different categories, the browser one, the host internet protocol category, the integration with Metasploit that, well, it's being developed right now, network category, has a category for persistence, few modules to try to force the victim connected, and well, for each, yeah, well, if the module has the green color, it means that it's supported in this browser, and if it's red, means that it's not supported or well requires user interaction. So for each victim, we have a tab there, so we can control individual victims and well launch commands to them. So we're going to show the network reconnaissance toolkit. So well, first of all, this is the discover internal IP address. So well, we send that command to the victim. The victim executes the JavaScript code and then returns back that string to the admin panel. So here we have the IP address. In this case, we are running in the same machine, but will appear the IP address of the victim. Then we can try to run the pin sweep module. For that, we need to know before the in which network is the victim. So we set, for example, 50 machines, and then just hit execute. And well, if we wait a couple of seconds, we start to receive the hosts that are alive. So here's the list. Now we are going to run the DNS enumeration module. So the module comes with a default dictionary of host names, but you can provide whatever you want. So same idea. It takes a while to launch the command, but well, in a while we start to receive that DNS entries that are in the intranet of the victim. So well, now well, if we come back to the ping sweep command, we can get the full list of the hosts that are alive. So we're going to pick like well this one machine, and we're going to see to run a port scanning on that.
Okay, so now in the port scanning thing, you provide the IP, the list of ports. Well, I'm going to remove the default one. I'm going to provide just a list of ports I want to scan in that machine, then the timing that I will leave as the default values, and it works. Well, it will run in the victim, so I will start getting where those values. It's important to know that the method we are using here is being seen in other tools presented in other conferences, like for GS Recon, which was performing a WebSockets port scanner. But those tools were using only the WebSockets method or the CORS method. We are using the three of them combined. For example, sometimes the WebSockets results are not very reliable, and then you want to use another technique to double check that. So we are using these three methods to check that really that port is open. Or sometimes the classic approach will tell you that port is open. Then if you run the WebSockets, it will tell you that port is filtered because you can access it. It's a bit more accurate. So that's interesting, and it will give you a bit more of information. Which is well, as you can see, it gives you the service, which is if it's port 22, it's no, it's sort of 21. So now we know that we have a set of machines, a number of machines that are alive with a few ports open, and other machines that we want to just show them in the nice diagram that I was talking before. So this is that you can embed the diagram there and then just put that in your report for your pen test, which is, it's not too bad. Like you can just move it around and then make it look as you like, just a bit of eye candy. And yeah, as you can see different icons. That was because of the ports, the OS basic fingerprinting. If the TUX displays, because the 22 is there as open. So that's the basic OS fingerprinting that you can just see with this diagram. And well, those were the tools that we developed as modules of BIF for the mapping stuff in the intranets. And now I'm gonna show you how the interprotocol looks like, just sending some commands to the IRC. We picked up the IRC protocol, but we checked that other protocols, depending how is the configuration of the server and how is how many commands, roam commands will allow. FTP lets you run these things, and SMMTP as well, but it will have to be in a non-standard port, and there's few protocols that will swallow all the headers, so which is good. And now we just provided the channel that we want to send the message, the type of message, and then we just connect it using IRC to that server to see if the thing works, and the big thing will connect. And that thing is really cool because you can use well, it's being used in with some botnets IRC to control which victims they have hooked, and as you can see, it connects and it sends a message, so you already know that guy is being hooked into the thing, and well, it's pretty much it. It's all the build on the beef. You can just get the code and try it yourself. It will be in the next stable, which the code freeze is the 3rd of November, so it's 10th of November, the release. And just download it, and if you don't like it, or if you don't, if it doesn't work, just give us a shout and we'll probably fix it. Beef is quite an interesting tool and very nice because it already provides you as with a command control thing, and you can extend it. And it's okay, and it has a very long set of modules that are already implemented, and with the Metasploit integration, it's quite a powerful tool. And well, the good thing is that all this thing runs in the background of the website, and it's just JavaScript. So no antivirus or IDS or anything will raise any alarms. It's being already, there's some concerns of sysadmin that we know that's like, well, can we filter this? Can we add rules to that? And yes, you can, because, well, the client connects to the beef, not the beef connects back to the client. You can still catch some traffic coming back from there, but we already are working on some obfuscation tools to make the code to not be recognized by rules, or not be recognized as the server, so make it look like a harmless Apache server that is giving you some information, and well, just run the command to redirect the user to the URL. And well, okay, some conclusions. Well, the intranets are meant to be secure, but most of the time the companies rely on the firewalls that protect the intranets, but they give access to everyone who is connected to the intranet to the whole internet, so they can access forums that they are members, or Facebook or Twitter or Google account or anything. So any person can be picked up and make them run code in their browsers. You can also communicate with the machines that are within that, and well, we found that one good way to protect is just running no scripts in your Firefox to allow not allow any not known JavaScript code to run in your browser. But that was the only way we found that these things can be stopped. This is the new features of HTML5. So well, we really like to abuse them, and well, they're trying to push these things forward without checking what's the consequences. But that's good fun. And in my opinion, the browser should block these kind of requests, but you know, sometimes they don't care. And well, that was it. Here you have our Twitter handles. So if you have any questions, give us a shout. Or anyone has a question? Yeah. Yeah. Like the kind of having a distributed thing to share the session between different things. This is one of the things that we will have to look after. It's in the to-do list, using web workers to parallelize the requests. So instead of relying only in one website that is infected, just try to break it up and then send it in different many times, and you can do that. But at the moment, it only relies on if you have the tab open or the window, then it will run. If the guy leaves, obviously the connection is lost. But there are some modules on Beef to make the attack persistence, like hiding the attack, the thing in a hidden iframe, or kind of do tap nabbing or click jacking just to trick the user into he doesn't know really what's going on. But yeah, that one of the things that we are looking into to implement. There's another question here, yeah. $25? No, it's blocked. 25 is blocked, and that's very blocked. That's not easy to work around. You can, for example, work around the limit of the 22, but the 25 seems to be blocked everywhere because of the span issues. So if SMTP protocol will swallow the inter-protocol thing, but if it's configuring a non-standard port.
Yeah.
That was the only one that we couldn't work around. The others, there's a long, if you go to the, well, the port scanning have a list of ports. We just found them brute forcing. We have like, we put from 0 to 65, 5, 3, the maximum number of ports you can configure, and we just checked what the response was, and that's the list of blocked ports we know they are for WebSockets and cores. Then Firefox is a different story because the block is natively, so it's smaller, but still we are taking the biggest one because then if it's blocked, we notify that the port is blocked, but still, even if the port is blocked for WebSockets and cores, you can still run the classic approach. Yeah. Yes. Yeah. It's based on the, obviously you cannot check the response, but just if you have the timing event saying the error was raised because the resource was not loaded, then you know that the connection was not made, so that's a closed port. And then if the connection attempt was opened, then there is no question because the protocol can't stay the communication open. It can close the connection, but the protocol won't mismatch, so the communication will stay open. But you can then control that using WebSockets and cores. No, it's because it won't connect to FTP, the protocol. If he wants to connect to FTP, then the protocol will match, and then it will ask the user. But this time you are loading an image, which will send you into a resource that is the image, which will either try to load it or not. If it loads, then then you can capture the event for open port, and if the port is open. If it doesn't, then it's an error, and then you can capture that as closed. So, no problem. Any other questions? Well, I will be around, so if you have any other questions or anything, just give us a shout. All right? Thank you.
Thank you.